Thank you for joining. Today, I'd like to present some preliminary results from an analysis of the impact of U.S. state-level policies banning sales of electronic nicotine delivery systems, or ENDS, products. This research was conducted by the Health Economics and Policy Research Team at Juul Labs, and all co-authors are Juul employees. In fall of 2019, several states passed short-term emergency bans on the sales of ENDS products in response to an outbreak of vaping-related lung injuries that the CDC has strongly linked to THC vaping products. We sought to understand if these policies have unintended consequences, such as an impact on cigarette sales. In this study, we utilize a robust econometrics method, generalized synthetic controls, to assess the impact of ENDS bans on cigarette sales in 3 U.S. states that passed temporary bans on ENDS products in fall of 2019: Massachusetts, Rhode Island, and Washington. This type of model can be used to predict a counterfactual for each state with a ban, and our initial findings demonstrate that cigarette sales in states banning ENDS were significantly higher than would have been observed otherwise. In order to model the impact of a policy on cigarette sales, we need to account for a number of other factors that can significantly affect this outcome, including seasonality, economic and demographic characteristics, national trends in smoking and vaping prevalence during the evaluation time period. GSC is able to account for these factors and weight the non-ban or control states to compose meaningful counterfactuals for the states with bans, or the treatment states. We utilized GSC to create a robust model to predict what cigarette sales per capita would have looked like in each state with the ban policy if a temporary ban had not been enacted. Predicted sales were then compared with actual weekly cigarette sales per capita in states with bans to establish whether there was a statistically significant difference between observed and expected weekly and cumulative cigarette sales per capita. Numerous robustness checks were also conducted to validate the results. As I had mentioned, we focused primarily on 3 key states that enacted a short-term ban: Massachusetts, Washington, and Rhode Island. We also looked at 2 other states, Michigan and Oregon, which enacted a ban that was revoked by courts just after going into effect. If our hypothesis is correct and ENDS bans have a direct impact on cigarette sales, we would see no impact in these 2 placebo states where the ban didn't actually go into effect. We used the remaining states as controls to generate counterfactual trends for each banned states for our outcome of interest, which was weekly cigarette sales per capita. This figure demonstrates our results for Massachusetts, which banned all ENDS products for 3 months. The dashed blue line demonstrates the weekly cigarette sales per capita that is predicted by our model. The black line shows actual sales during that same time period. The white section on the left is the time period prior to the ban. As we see, both lines track very closely, suggesting that our model does a reasonably good job of predicting cigarette sales for Massachusetts. The gray period on the right is the period after the ban goes into effect, and as we can see, the lines clearly diverge, as actual cigarette sales were significantly higher than predicted. On average, weekly cigarette sales per capita were 8% higher than would have been seen otherwise in the post-ban period. We see similar results for the states of Washington and Rhode Island, which instituted bans on flavored ENDS products only in the fall of 2019. The white period on the left side of the figures demonstrates that the model performs reasonably well in the pre-ban period, and we see a similar effect in the post-ban period. Weekly cigarette sales were 5% higher than would have been expected in both states during the flavor ban period. Finally, our findings for the 2 placebo states that passed a ban that was later revoked show no impact in the period where a ban would have occurred, as both lines follow the same pattern in the white and gray periods on this figure. This suggests that lack of ENDS availability, rather than external factors such as smokers' risk perceptions, were the main factor driving our finding of higher than expected cigarette sales during a ban. This work provides strong evidence with causal inference methods that banning ENDS products can have unintended consequences. Cumulatively, our results suggest that over 3 million additional cigarette packs were sold in banned states during the ban period than would have been sold otherwise. The observed impact on cigarette sales was also greater for a full ban on all ENDS products as compared to a ban on just flavored ENDS products in Washington and Rhode Island. These findings were robust to multiple specifications and robustness tests. Future research is still needed on the potential spillover effects of these bans and any potential long-term impacts. However, these initial findings suggest that we should be aware of the potential consequences of ENDS-related policies. Please contact me if you would like to know more about our methods and our findings. Thank you for your time.